Hi my friends, today we model this part. It is interesting because you see in the drawing that there are two centers here. One center is for the ring and the other one is for these two protrusions. They are centered on this line and this line, and we place here 10 degrees because this line is not equal to this one, and same for the other two. We start by creating the ring. Dimensions are here, and let's start. New standard millimeters IPT, XY plane, and we draw a first line of 41. I go up and 2 steps are here. Close. This line is a center line and dimensions are 14.3 is this one, 4 is this other one. Diameters, this is 180. Next one is 160. No, 170. And the last one is 160. Fully constrained sketch, but I draw this line on a diameter of 130. I don't split these two because we have two clear and visible areas. Revolve. What to revolve? This? No. This? Yes, sir. The axis is also known, so we have the first volume. We continue with this protrusion, extension, call it as you want, and we have to be careful with this point aligned with the second center. Let's do this. I turn the part as you can see, and I draw a circle with the radius of 140. I place this with the center on the same vertical with the center point. This is the center point of our part at a dimension of 5. Then I draw a line from this center, not this center, to the circle, tab, and now I place the dimension 180 minus 20. The dimension is 20. I eliminate this dimension and I place this one because this is in the drawing, my friends. You see this horizontal is automatically created by Inventor when I placed the angle. Then I draw the two lines. One is this one and the other is this one. Angles are 10 for both, 10 degrees. Then I apply trim of this arc and this arc, and I place the midpoint of this arc on the end of the line. These two are construction. Then I place on the same horizontal. You see we have 1 dimensions needed. These 2 points on the same horizontal. Now it is a fully constrained sketch. Finish sketch, extrude this the other direction of 16. All dimensions are in the drawing. Now we want to create the other protrusion, this one. Dimensions are here. You see there is an angle of 7.8 degrees from the vertical and 10 degrees about this axis, radius 15, distance 170. Let's do this. We turn the part and we select this face. Now we see that the coordinate system is not aligned with horizontal vertical. In exchange, we see this as a horizontal axis. Well, this happens because the sketch coordinate axes are generated by an internal algorithm based on the contour of the surface selected when creating the sketch. In our case, the algorithm chooses this line of the sketch. I found out what to do in this case by consulting with my friend Johnson Shui from Autodesk. Thank you, Johnson. We project the y-axis. This is the axis we need to create that angle of 7.8 degrees, and then we use a special tool, Edit Coordinate System. Click on it and we have here the axis X and Y. I select this axis and I hover on the vertical. Okay. Now if I select this, we have a vertical axis here, even if the sketch is rotated. You see coordinates. Good. Now I change the background color to be more clear. High contrast. Okay. You see we have 2 points here. The axis of the new protrusion is 170, and I place the angle of 7.8. Good. Then we can draw the contour of this new protrusion line. Press the left button, go somewhere, but I accept that the tangent constraint. I apply angles, but let me place this point coincident with the end of the line. Then angles 10 and 10. You know why? Because this is the center we use, not this. If we use this, we can place equal to this two. Very important. This is radius 15. Now you see the colors. The sketch is fully constrained. I don't make this construction because we have a contour here. Finish sketch, extrude, we have a separation because of this axis, and the other direction to this face. Okay, I go back to normal background, Alt F(I) in sequence to obtain this application options. You know this from my previous tutorial. Okay, next feature is this. You see here this extrusion, then a cut. Dimensions 125 is the distance of this. Yes, this must be extruded to obtain 41. 41 is this dimension, so that we use 2, not a value. Good. I select this face, then I make visible this sketch, visibility, to see where is this point, because we use this one and not this one. I draw a line here, horizontal, then another one. No, this is horizontal. Dimension to this. I didn't project the point. I project this point, then I place the dimension of 125. Finish sketch, extrude this to the face. Okay. Now I hide the sketch. and we continue with that cut. The cut is 35 from the center and 24 with 6 on the back face. This is the back face. Okay, we create a new plane based on these two to have a mid plane. Then we use it for a new sketch, F7. I project this line, then I create a rectangle. You see this dimension is 24 and here is 6 and this dimension is not to that Control Z. We have to project also this arc, and we have a line here. The distance from this face to this is 35. Finish sketch, extrude. This is the cut, with cut symmetrical all the way. Yes. Okay, I hide this plane and we continue with other features. There is a hole here with diameter of 16. We apply hole. This is the face, this is the center, and the diameter is 16 through all. Okay, then we have to place this cut with the hole. Dimensions are radius 144 divided by 2 for this point, and the angle of 16 divided by 2 because we use this face. Okay, I turn the part and I select this face for a new sketch. Then I make visible this sketch because I want to use this point and this axis. Again, as you can see, this is with this line horizontal. Let's see how is now. Now we have this as a vertical. Very good. I draw a line from this center, not this center, at a distance of 144 divided by 2. I project this line to have a reference, and I place here an angle between these two lines of 90 plus 60 divided by 2. Good. Then I draw a line starting from here. I hover this line to obtain a parallel. I press the left button. I go here and back to the circle. I make coincident these two and I apply the radius of 7.5. Fully constrained sketch. Finish sketch. Now you see that the depth of this cut is 9. Extrude this as a cut on 9 millimeters. Okay, I hide the sketch and you see there is a hole 5 of diameter 9 with this center. Good. I apply hole on this face with this center and the diameter of 9, which is already selected. Good. What next? Next we have 5 instances here on angles of 60, so that we don't have 360 degrees, but 360 degrees minus twice 60. We use this. We apply circular pattern for the two features above this axis in number of 5, 360 minus twice 60. You see here the disposition of each feature or cut. The part has some fillets. You see radius 5 these two and radius 10 1, 2, 3, 4. Let's apply. I select firstly this edge for 5, then plus 10 to 1, 2, 3, 4. Okay. I verified the model and I saw that this sketch is wrong. You see, this arc has a center here, but this is not a center because these two faces are with angles, so that I eliminate this, also this, and I finish this. I apply move EOP marker to this moment. I create an axis using this, and now you will see that this point is upper than this line. I place this axis here to use it. I double click the sketch. I project that axis and I place dimension of 35 from that axis to here. 35. Finish. Move EOP to end, and now we can compare the two parts. Eye properties, physical, update, copy, close, drawing, double click, and paste. Oh, there is a small difference at the third rank, very small, so we consider this as the result of what we did here. We go to material, steel carbon, view, default lights, and now we compare the two. There is a difference, but I don't know what is that difference. Let's see from the other angle. No, it was only a difference of angle. Okay, that's all for today. Thanks for watching. Bye bye.